I guess you guys get confused with this. Let me just read some comments. This formula at the bottom is not available in the book. I guess let me just deal with this. Let me just enter the data and show you how this distribution can fit in. Just a second. Let me just check if I have a data ready-made. Let me just explain how normalization can be useful. Let me just at least take a random data. Let me just create a data, okay? This is student registration number, okay? So let me just create a dummy data and then I'll show you. This is a, let's say here we have a 99 students. Let's take it 100. So you can understand in a better way. Okay, now let me just decide their marks. Randomly, I'm just taking, okay, randomly I am deciding their marks out of 100 using this formula, random between. Okay, so I've assigned the marks randomly, okay? So this is a dummy data that I have created, okay? Now, let's say this is a 4 grades, A grade, B grade, C grade, D grade, and F grade, okay? F grade is marks up to, you can say that marks up to 0 to, let's say 35, F grade. Then 0, and then let's say 35, 36 to, let's say 45 is, let's say, a D grade, okay? Then 46 to, let's say, 55 is, let's say, C grade, okay? 55 to, let's say, 65 is, let's say, B grade, okay? And 66 to 66 and above. When I discuss the normalization, this range is not suitable, okay? I know that, but don't have much time, so randomly choosing the ranges for the grades. Okay, let me just assign this formula and let me just assign the grades to the let me just log the table. I need to log the table actually. Okay, this is the third column, approximate match. This is F grade. These are the random marks. Let me just check it. Okay, 35, it's F grade. Okay, this is a 14 were there, right? Okay, So formula is correct. So this way I've assigned the grades. Okay. As I said that this is a normal distribution, can't deal with the discrete data. So marks ka data, if you observe, it's a discrete figure. So normal distribution, I mean, it's okay if you, it's better if you, let's say, convert the data into the continuous. So I have formulated some groups. So the data was ungrouped. So this data, let me just highlight, the marks data was ungrouped. I formulated some groups. Okay. Now, let me just at least calculate this. Okay. Let me just at least have the frequency of this. So this way you can at least summarize, prepare the summary of it. Okay. So F grade is like this. This is F. After F, there's a D grade. There's a C grade, 10 people, you can say. This is a B grade, 10 people. In A grade, there is a 32 people. Data is not at all normal. Okay. Do you want to see that? Let me just at least show you using simple bar graph. Data is not at all normal. See, this data is not normal. Okay. Now let me just show you the normal data, how normal data look like. Okay. Just keep observing my graph. I'm changing some observations. Okay. And I'll show you the normal data. So how the normal data look like based on this frequency distribution, because as I said that if you draw the frequencies and if you plot the probabilities associated with the observation, okay, the pattern will remain same. That we had already discussed in the last session. Okay. So here, let's say 10 people. Here, let's say 10 people. Here, let's say 20 people. Sorry, 15 people. Let's say 15 people. Okay. Sum has to be 100. We need to take care of that. Okay. Here, let's say 20. Let's say 30. So this is a normal distribution actually. This is normal distribution. Oh, sorry. Has to be. Okay. Here you can say this is a normal. Can you observe the bell-shaped curve? Now this is normal. Now this is what? Based on the frequencies. This is based on the frequencies. You need to calculate the probabilities also, right? Many times based on the frequencies, if you don't get the normal curve, so people used to at least standardize the values. If the values are too big and it's very difficult to handle. Let's say if you're dealing with the population figures or let's say migration figures, then you'll observe very, big figures here. And let's say sample size here, the sample size is only 100. I mean, if you are dealing with the large size data, definitely uh, it's like very difficult to deal with the actual observations many times. Okay. Uh, so in this kind of situation, why don't you at least convert this? So two things you need to at least understand. Z value. What is a Z score? Z score is nothing but, first of all, you need to find out the average value of this. Okay. And then you need to calculate the standard deviation. These are the mean and the standard deviation. Now, each observation minus mean need to be locked, because that is going to fix for each and every. Mean need to be fixed for each and every observation, right? Now, this is the standard deviation value, going to remain same for all. Okay, this is a z-score. Let me just at least sort this data as per the lowest marks to the highest marks. Sort this data from based on the marks, lowest marks to the highest marks. Can you observe the lowest possible? This is a standardized value. This is a standardized value. Try to understand the concept. I'm considering each observation. Okay, subtracting average value out of it and divided by standard deviation, normal deviation. This is what? This is a rescaling of entire range of the data. This is a rescaling. So we are just nullifying the effect of unit. If these are the marks, if the observations are, let's say, GDP figures, if observations are migration figures, if observations are quantity of some, let's say, liquid substances, solid substances, we're just trying to nullify the effect of units. Okay, if we standardize the values. Can you understand this way? Yes or no? Can you understand this way? Ankit, I was expecting that question from you. Ankit, I believe that if you understand concept, it's like very easy for you to solve certain examples. And see, Ankit, it's not, I'm not only teaching you for exam. Okay, it's not only for exam. I'm glad if you can at least understand this concept and utilize it after this program. Okay, I just want that whatever I'm discussing should be beneficial to you after, let's say, passing this course on also. That's what my goal, and that's how I develop my pedagogy. I design my pedagogy. Okay, so Z score is, can you observe, this is a way of standardizing it, -2 positive. Now let me just tell you that how the same thing can be. Well, this data is not at all normal, so you're not going to, let's say, if you plot this chart, then also this is not going to work. If you go to the recommendation, look at this. Even the bar and the any chart is not normal. Okay, so this chart, this data is not at all normal. That's why. But this is how normal data look like. If the frequency distribution is this, if the grade distribution is, if let's say 10 people are have let's say secured F grade, 20 people secured D grade, this is how it looks like a normal. Okay, okay, at the end, can I can I Vina, can I at least show you at the end any doubts regarding Excel at the end? Okay, because currently I'm discussing, I'll discuss at the end, please. Okay, at the end I'll discuss. Now let me just discuss how what kind of problems are there given in the book as far as the normality is concerned. Okay, uh, so here they have just try to exemplify that. Just observe, let's say in particular data, let's say the average value is 50, standard deviation is 5. The second case is average value is 80, standard deviation value is 5. In the third case, average value is 50 and standard deviation value is 10. Now observe their curves. Can you feel that standard deviation decide the shape of the curve? Can you feel that the standard deviation value decide the shape of the curve? Yes or no? And observe the location. Observe the mean. So here in the first case, average value was 50. In the second case, average value was 80. In the third case, average value of 50. Now, can you say that standard deviation, as standard deviation decide the shape of the curve, mean is deciding, is just try to at least decide the location. These two curves are located here. This third curve is located here. जिसका mean 80 था. So location parameter क्यों कहते हैं mean को? The reason is that decide the location of the curve. Okay. Now what kind of examples? इसका एक simple example मैं दूं कि जैसे कि एक class. This is class 1, class section A, let's say. Here, let's say average marks are 50. And let's say in class B, let's say average marks are 60. Can you observe the shift in the curve? The curves are not coincide because the location of curve A is left to the curve B. Why? Because in class A, the average marks are less than the average marks of class B. So this way, average decide the location and standard deviation decide the shape. Okay, mu decide the location. Okay, got this? It's a standardization, Himani. It's a standardization. It's a standardization used to make the calculations very simple. Okay. Don't, I mean, just try to understand. If you are having this big figures like 1 lakh crores and 2 lakh crores and 3 lakh crores, and if I ask you to find out average, okay, using let's say simple calculators. Imagine the era uh, before before the 40 years. Okay, 40 years back, people have to calculate this kind of things manually, and when you're dealing with the big figures, you need some easiest way. So if you remove the base, calculation is like very easy. Can you understand this way? See, normal distribution formula is this. To calculate, let's say I want to understand that I'm dealing with the sales data. So let's say, what are the chances that for a particular day, let's say my sales of my product is above 5,000. Sales data maybe in the thousands. So again, 1,000. So all those 1,000 variant, 40 years, that concept is like very much old, but up to 40 years back, I mean, I'm talking about, let's say, the 50, 30 calculators, and they had calculators, but they didn't have computers and the softwares. तो आपको calculation आसान बनाने के लिए बड़ी figures, when you are dealing with the big calculation. Can you understand my point? That's why this is a standardization. This is a standardization. Can you understand what I'm saying? This is a way to standardize. Himani, Snehal. Yes, Daman. Sigma, sharpen the curve. I mean, just try to at least decide the shape of the curve. That's how. Imani, Snehal, I hope you are listening to me. What about the other people? Have you understood? This is a way of standardizing it. And what is the use of standardization? To ease the calculation. When you need to calculate the things manually, if you are dealing with the GDP figures, look at this formula of normal distribution. If you want to find out, let's say for a particular state, let's say in the next quarter GDP is above certain range, then you have to deal with those big figures of GDP, and you have to churn the number using this formula. Imagine, it's very difficult. You need to at least, rescaling the observation so you can at least ease the calculation. This is a rescaling of the observation. This is a way to rescaling the observations. I hope I am audible properly. Am I audible properly? Yes or no? Now I need to know from you. Am I audible properly? Yes or no? Now I am asking to you, what is the use of Z? What is the use of Z? Why we are finding out the Z? Why we are saying this quantity can be considered as Z? Tell me. What is the use of standardization? Let's try to at least understand from the scratch. What is the use of standardization? Ease of analysis, yes. Ease of calculation, not analysis, ease of calculation. Because if you imagine about the softwares are there in last 30 years, okay? Softwares are available, okay, since last 30 years to 40 years, you can say. Before that, people used to calculate manually, I mean. So you can understand the standardization like this way. Let's say if these are the figures, this is a very simple way of doing it, okay? If these are the figures, many times you just write like this way, and on the top of the head where you just write the heading, you just put that, okay, figures are in thousands. Can you understand? Figures are in the thousands. Even to show the data, you are using this kind of funda to at least represent the data in a very simpler format, so people can understand. Figures are in thousands. Okay. Yes, Shrishti. Okay. So now let's try to understand, and it's very easy also. Okay. So it's very easy to calculate the probabilities, because why we are using probability distribution? To calculate, to know the chances of certain events will happen. What kind of certain events? Let's say certain observation will appear in our data. We are curious to know the chances of that. And if we, for the calculation of that, if we need to at least use this kind of heavy formula, imagine, look at the difficulties that may come in order to at least calculate the probability. If we don't find a shortcut, it's like very difficult to at least get the answer. It is very time consuming, right? Now let me just give you the simple example. I have multiple examples, but I'll upload this PPT and then you can at least check it out. Other examples, let me just give you the simple example. This is the simple example, simplest one. Okay. So let's say 1,000 bulbs with a mean life of 120 days are installed in a new factory, and their length is normally distributed with the standard deviation of 20 days. I'm going to discuss this example and one from the book. Okay, this will I'll discuss the normality concept. Okay, how that can be applicable. So let's say here the experimenter must have checked the life of 1,000 bulbs. So in one production run, they had 1,000 bulbs. So they must have checked the life of each and every bulb. Just like this is the first bulb, they must have checked the life of this bulb, whether it's working for, let's say. So this is how the life testing process of the bulb must be carried out. They must have gathered the data in Excel file. Bulb number 1, life is so and so days. Bulb number 2, life is so and so days. Likewise, they must have at least gather the observations of that experiment. Now at the end of the experiment, they must have calculated the average life. So here we have given the summary of the experiment कि बल्ब की एवरेज आयुष्य कितना है 150 120 दिन. So the average life of the bulb is 120 days, but there may be variation. Okay, that can be vary up to 20 days. Now here is a question: how many bulbs will expire less than 90 days? Great. So this is confirmed. Now this is what it's given in the question. In your exam, this kind of statements will be there. So you should understand this is a problem of normality. Okay, this is how you should identify whether the problem is of normality or not. So यहाँ पे this is the average 120 days. Now there are two type of normal curves. This is a normal curve based on the observations. This is a observation curve. Okay. Now we need to, when we rescale the values, okay, the same graph can be plotted, the same, similar, exactly same graph can be plotted for the Z values, corresponding Z values, I'm saying, okay, Z values, okay. Here we have 1,000 observations. Here also we have 1,000 Z values for each and every bulb. Here the observations are nothing but the life of each and every bulb. Here the Z value for those 1,000 bulbs. Okay, so the curve will be exactly same. Okay, due to my poor drawing, I am unable to at least make it exact, but I'm telling you verbally. Now, what is the procedure? We need to find out the Z. We need to so for the simplification, either you just at least use this formula. Either you use this formula, or you can at least apply the Z concept. So Z concept is the easiest way to find out the probability. We need to find out the probability when bulb is surviving less than 90 days. For this event, we don't know the Z value. We need to find out the Z value for this event. Okay, so that can be calculated using this formula. So here 90 is the days. So what is the concept of Z? Observation minus mu divided by sigma. We are calculating probability for this. Z is less than x minus mu by sigma. That is, capital Z is less than 90 days minus average life 120 days divided by variation of 20 days. Tell me what is it? What it is? Tell me this. Tell me this. This one. Tell me this one. 90 minus 120. Is it minus 1.5? Is it minus 1.5? Rajiv, graph is not much essential, but it's just for your understanding. Rajiv and the other people, if you are perceiving that in exam you have to draw the graph, it's not mandatory. Just for your understanding, to at least give wings to your visualization. See, Rajiv, in decision science, you have to have that kind of capability to visualize the data, visualize the structure of the data. That's why I have drawn the graph. Okay. Now, as I said that there could be two type of Z values. So यहाँ पे this is a negative side. This is a negative side of Z value. This is a positive side of Z value. Okay. We need to find out the probability that bulb is surviving. This is a 0 days. These maybe 200 days. Okay, 0 days. So this is a 90 days. Somewhere here the 90 observation would be there. So we need to find out that probability that bulb is surviving up to 90 days. मतलब यहाँ तक जिंदा रहता है bulb. This is a highlighted part Okay, and we need to find out the probability of this curve. What is the full probability? What is the probability or the total probability of the curve? Let's say here the probability value could be 0.0, here is 0.5, here it's 1.0 probability. So these are the probability figures. Can you understand why this is, why here at the average value probability is 0.5? Because normal curve is symmetric about the mean. What does mean symmetricity? Symmetric about mean मतलब जितने पॉइंट्स, अगर यहाँ पे 50 डेटा पॉइंट्स हैं तो यहाँ पे 50 डेटा पॉइंट्स ही होंगे. हो सकता है ये रियल लाइफ में ये 49 हो और ये 40, ये 50 हो. इट्स ओके, इट्स अप्रोक्सीमेट normal distribution, but symmetricity is approximate symmetry. Okay, yes, that's why probability also. So can you imagine the probability like this way? Now here on the z value you need to find out. See, this is based on the observation. Now if we, let's say, look at this, we don't know the corresponding value of this. So corresponding value of this we don't know, corresponding z value of this we don't know. Okay, इसीलिए हमने ये कैलकुलेट किया कि करस्पॉन्डिंग z वैल्यू ऑफ 90 डेज इज -1.5. दिस इज -1.5. तो ये हिस्से का probability we can at least find it out using z table. So this is a snapshot of z table. I'll attach this z table. Okay, so in the z table these are the negative values. Here in the first column, okay, so these are the z values with 1 decimal point. These are the z values with 1 decimal points. यहाँ पे second decimal place बताया गया है. Okay, so the our z value is -1.50. Second decimal place is applicable, which is 0. So this one. First decimal place is 5. Okay, integer figure is -1. So this column can be selected, this row can be selected, and this is the intersecting point. So this is appropriate value for us. So probability is what? The probability of this. So now let's talk about the actual observation. Probability that bulb, any randomly chosen bulb can survive up to 90 days. The probability is 0.066. मतलब 6.6% chances है that random bulb can survive up to 90 days and won't survive after 90 days. Understood this? Not 66, 6 point. Okay. Understood this? Yes, no? Now, we need to multiply this probability. As you say that probability are the relative frequencies. Okay, you can say that at one time you can say that, okay, probabilities are what? Relative frequency. So ye proportion, say if I multiply 1000, that means 6%, 6.6% chances are there that bulb can survive up to 1000, up to 90 days. So multiplied by total number of bulbs being tested. So we have tested, that experimenter had tested 1000 bulbs. Multiply this probability. So we can say that 67 bulbs are expected to expire before 90 days. Do you understand now? Are you clear with this? Are you clear with this? Yes or no? Let me just take one more example from the book. Okay, if it is not given, it's okay. I'll at least, okay. Now, here they are saying that According to the EPA data, okay, Environmental Protection Agency, EPA, okay, on average, there is a 4.3 pounds of waste generated per person in US per day. Suppose the wastage generated per person per day in US is normally distributed. We need to underline that fact. मतलब bell curve observation से मिलता है, because they say that they must have checked the normality. Okay, they must have done this exercise. Once they have gathered the observation, okay, they must have converted the data into group data, and they must have at least checked the normality like this way. Okay, so we need not to at least check the data because we don't have data either. Okay, so this is what they are saying. Based on their data, they calculated the probability, they calculated the average waste generated, average wastage generated per person per day in US is 4.43 pounds. Okay, now it's normally distributed, and the standard deviation is 1.32 pounds. 1.32 pounds. If US person is randomly selected, what is the probability that the person generates more than 6 pounds wastage per day? You have to visualize this. You have to visualize this. This is a normal curve based on the observation. What is the average wastage per person per year, per day? 4.43. Somewhere here it could be 0. Okay, we don't know the upper limit also. Okay, now what is the standard deviation value? This is a mu. They are saying that 1.32 pounds. Standard deviation value is what? Standard deviation value is 1.32 pounds. Let's keep it aside. What is the probability that the person generates more than 6 pounds? More than 6 pounds. Maybe somewhere here, more than 6 pounds. More than 6 pounds. This side. We need to find out the probability of this area. We need to find out the probability of this particular highlighted area. We need to convert these figures into the Z values, standardization. So we can at least make a use of Z table. So this is a Z curve. Okay. We need to calculate this. Okay. At this place, we need to calculate this. So this can be calculated. Z equals to x minus mu divided by standard deviation. That is 6 minus 4.43 divided by standard deviation is 1.32. Can you tell me the Z value for this? Can you tell me the Z value for this? 1.19. So at this point, Z value is 1.19. Okay. Now listen to me very carefully. We are going to make a use of Z table. In order to find out the probability, we are going to make a use of Z table. लेकिन Z table में कोई भी Z value के लिए probability दी जाती है from extreme left. 1.32. We want probability for this area, which is not directly available from the Z table. What is directly available from the table is the probability of this area. From extreme left to Z equals to 1.3. This is available. Okay, this region is known as, this region can be said mathematically, this can be said Z less than 1.32. Lekin we are looking for probability X is greater than 6 pound. So probability that Z is greater than 1.32. This is what we want to find, which is not directly available. What is available? This is available. Okay. What is a full, what can you tell me this? Z greater than 1.32 plus probability Z less than 1.32. Can you say that total probability is 1.0? Can you say that total probability is 1.0? Yes. Great. So let's find out the probability, what is available from the table. So let me just open the table in front of you and let me just show you that how you can read this table. So this is an embedded file. So these are the negative Z values. So the first column Z values are given. First row and first column. Let me just highlight. So these are the Z values. So यहाँ पे Z value with the first decimal place is mentioned, and for the corresponding second decimal place, you have to refer the columns. But these are the negative values. We are looking for positive value because in our case, the Z value is positive 1.32. So we need to refer this. Now, can you tell me where is the 1.32? So this is 1.3. Can you understand this? Let me just highlight this. So this is 1.3. Let me just highlight this with a yellow color. This is 1.3. But our Z value is 1.32. This is 1.30. So for the second decimal place, we need to refer the column-wise outputs. So this is 0. This is the second. Okay. So let me just highlight this also. So this is the intersecting point. Got this? Is it clear? Is it clear to each and everyone? This is very important. Any doubt, I can repeat it at this point. Most of you are saying yes, but it's very essential for me to know that all of you just got this. How to find out the Z value here. Is it clear?